Good afternoon, ladies and gentlemen. Let's start on time, Greek time. Any time is good time. This is, in my mind, the most interesting session that we are having during this conference. It's health and safety. We are trying to get on the same table the medical profession and the engineering profession to solve our problems, not as we think they need solving, but as they want to be solved. And it gives me great pleasure to have a dear friend, Sani DIMITROULOPOULOU, that I have to read the CV. Sani is a principal environmental public health scientist on indoor environments at UK Health Security Agency. I still prefer Public Health of England, the old title. She's also a visiting professor at the UCL Bartlett School in the UK. She works closely with colleagues from UK government departments and organizations, such as the World Health Organization and CIPSE, Chartered Institute of Building Service Engineers, to provide expert advice on indoor air quality and health. You're welcome.
Can you hear me now? Yes. Thank you very much, Dimitri, and thank you very much for your kind invitation. It is my greatest pleasure to be here today and present on the impact of climate change policies on indoor air quality and health. So, as it was discussed also this morning quite extensively, climate change, the world actually today is facing the climate change challenge, and climate change changes the outdoor environmental quality, and in that case increases the outdoor temperature and relative humidity, which however can have an impact on indoor air quality, because it increases, for example, the emissions from indoor sources and materials, or this leads to implementation of more air conditioning, the need for more air conditioning, which may increase the indoor concentrations of pollutants, because in this case we provide more cooling but not really ventilation. As a result, the concentrations of pollutants may be increased. Furthermore, climate change may lead to extreme events which are more often happening, and they are more intense as well. And we all can be aware of flooding, which leads to mold and dampness in homes or public buildings. We're aware of wildfires as well, which increase the levels of particles in the outdoor environment, which eventually penetrate into the indoor environment. And of course, storms can lead to the increase of and the use of portable generators, which eventually may increase the exposure to carbon monoxide. And of course, we have all these mitigation and adaptation measures, which actually is the topic of my presentation today, and we're going to discuss about that, which all of them can have an impact on indoor air quality. But why do we care about indoor air? I would like to start by reminding you, first of all, of the factors affecting indoor air quality, starting, first of all, from the ambient air, with emissions from traffic, from industrial activities, from building sites. Then we have the urban planning, which defines the urban form, and in that way the dispersion processes in urban areas. And since in that way it defines the concentrations of the pollutants on the building facades, the pollutants which eventually penetrate into the indoor environment. Of course, the design and the maintenance of the buildings plays a crucial role, because any cracks or gaps in the building envelope may lead to the unintended ingress of the outdoor air pollution into the indoor environment. Ventilation, of course, plays a central role in the whole process. However, as we say, it's not really the panacea for any indoor air quality problems, because in terms of hierarchy of interventions, the very first is, first of all, to reduce the emissions in the indoor environment, emissions from building and construction materials, furnishing, consumer products, which are used, for example, for cleaning, but also from occupant activities, such as wood burning, cooking, smoking, or drying clothes indoors. and then to apply the adequate levels of ventilation in order to maintain indoor air quality. And of course, we have the pollutants which are generated in the indoor environment, which are generated from indoor sources, and I can mention, of course, the combustion pollutants such as carbon monoxide, nitrogen dioxide, particles or polycyclic aromatic hydrocarbons. We have also the volatile and semi-volatile organic compounds, again emitted from various sources, from building materials, from furnishing, consumer products, and we shouldn't forget, within all this mixture, the radon, which is emitted from the ground, and of course the biological contamination. So, we're coming now to the question, why do we care about indoor air? There are recent evidence reviews published by the Royal College of Pediatrics and Child Health in the UK, by NICE, the National Institute of Health and Care Excellence, again in the UK, and by the World Health Organization, which shows that exposure to indoor air pollutants, chemicals, and biological contamination is associated with impacts on the respiratory, nervous, and cardiovascular systems, but also with respiratory irritation, and last but not least, with carcinogenicity. Especially, and if we're caring about our kids, exposure to indoor air pollution can influence actually our kids from birth and infancy at the various stages of their lives, from birth and infancy to the preschool age and then the school age, causing respiratory problems such as wheezing, rhinitis, asthma, some dermal problems as well, eczema, dermatitis, and so on, and especially at the school age may lead to the reduced cognitive performance. We shouldn't forget, of course, the impact of the biological contamination of damp and mold. So, damp and mold in the home environment can produce allergens, irritants, mold spores, and all this can be harmful to our health. And also, exposure to damp and mold can affect our airways and lungs, and can cause also some serious illnesses, and in most severe cases can lead to death. And actually, the health effects which are reported here are part of the guidance which was developed by the UK government as a result of the inquest into the death of a 2-year-old boy, Ewop Isha, in the UK, who died from prolonged exposure to damp and mold in his own home. So the coroner asked actually the government to develop a guidance on damp and mold, on understanding and addressing the health risk, and this guidance was really dedicated to the renting housing providers in order to improve their understanding of the issues. So, any other respiratory effects include the general symptoms such as coughing and wheezing or shortness of breath, also the increased risk of airway infections may lead to the development or worsening of the allergic diseases. We shouldn't forget other physical health effects, such as the irritation of the upper airway system, eyes, nose, throat, and also the exposure to damp and mold may lead to the skin and other fungal infections. And of course, last but not least, we shouldn't forget that living in a home with damp and mold can affect also the occupant's mental health, because people may feel depressed, may feel anxiety, may feel isolated, they don't want to invite friends or other people in their own places because they're not proud of their own home, so all this may lead to mental health issues. Radon, another pollutant in the home environment. The fact is that radon increases the risk of lung cancer. The higher the radon concentration and the longer the exposure, the greater the risk. And in the UK, it is known, it has been estimated that radon in the home environment can lead to over 1,100 deaths from lung cancer on an annual basis in the UK. So, to go back to the climate change and link the climate change policies with the health effects, in the whole outdoor environment there are various policies for the various sectors. However, here we will focus really on the housing sector and the policies over there, the energy efficient redesign and retrofitting. We can mention the roof and the wall insulation, we can mention also the increased use of glazing, the improved use of glazing, double or triple, also the more energy efficient appliances, the use of more energy efficient appliances, and the lighting, and of course the heating, which has been improved. So there is actually evidence that climate change can affect our health and well-being through these adaptation and mitigation policies in the indoor environment. So we have this challenge here to understand the impact of these net zero policies, because net zero policies require significant changes in the performance of both new and also retrofitting buildings. The reality is that increasing air tightness in a building in pursuit of energy efficiency can increase the concentrations of pollutants which are generated from indoor and ground sources, but also biological contamination, especially if adequate ventilation is not provided in this case. So we do need to understand how current, how present actually, and emerging building infrastructure, design, construction, but also the materials which are used for insulation in the indoor environment may affect the indoor environmental quality parameters, and in that case, how they may affect our health and well-being. So there are various attempts actually in the past to estimate the impact of these policies. We can see various publications in these areas. We started back in 2015 with reviews. I can mention the most recent one, the HEC report, the Health Effect of Climate Change report, which is produced by our organization, and especially Chapter 5, which is on the impact of climate change policies on indoor environmental quality and health in the UK housing. And more recently, we were asked by ASHRAE to contribute to a book with a chapter on exploring the consequences of climate change policies for indoor air quality. And the results which are that I'm going to present actually today in the next 10 minutes is based on this review. So I will start with the positive side, with all the benefits that we can get as a result of these policies. And of course, first of all, this has to do that as a result of the policies, we're moving away from reliance on solid fuel heating. We're moving towards electrification, which in this case can remove any gas usage, any emissions of particles or nitrogen dioxide in the home environment or carbon monoxide. And in this case, we hope that eventually all these energy efficient measures will help to tackle energy poverty and address any inequality issues and of course any social challenges. However, we will see also, and I will focus now on the unintended consequences of all these policies, starting from the impact on ventilation. So the provision of adequate ventilation can be disrupted as a result of these policies. It has been reported from various studies that energy efficient ventilation systems such as EMEA, which are there to provide good indoor air quality, may not really fit for purpose, may not really fit their purpose. And this may happen if the systems are not well specified, designed, installed, commissioned, or eventually from the occupants if they are not understood, operated, or maintained properly. But it's not only the provision of ventilation, it has to do also, the good operation has to do with the continuous operation of the system. So problems have been reported if the occupants are not aware how to operate the ventilation systems, and especially if they turn them off because of noise issues. Now it has been reported that some forms of insulation, for example using vapor permeable materials, or additional measures such as trickle vents or air vents, additional air vents, and certainly if we encourage ventilation, then this may solve some of the problems which are caused by the failure of MVHR systems. And it has also been reported that the use of air conditionings, which discourage the use of ventilation because practically we are encouraged to keep our windows closed in order to keep the cooling in, may increase the concentrations of some pollutants. So at least no, actually, I would like to have your opinion here. It is recommended that air quality benefits can be actually achieved if we couple mechanical ventilation systems with air conditioning or with air purification systems. Talking about the impact of these policies on indoor air quality, there are European studies which shows that energy efficient retrofits, which are combined with mechanical ventilation, can reduce the levels of indoor air pollutants, the concentrations of volatile organic compounds, of radon, of carbon monoxide, dioxide, and also biological contamination. However, if the whole house mechanical ventilation is not implemented, then it may lead to reduced ventilation rates and may increase the levels of various VOCs. Of course, it was recommended in the various studies that if the provision of mechanical ventilation is not possible, then some additional passive ventilation systems should be installed. For example, they should use fans in the kitchens and bathrooms, which can reduce the levels of PM2.5 or radon and mold, but may increase the outdoor generated pollutants. And of course, these kind of conditions may have an impact on the indoor hygrothermal conditions in the indoor environment, which may affect the indoor chemistry and may affect the off-gassing of pollutants from building materials and increase the concentrations, especially of chemicals in the indoor environment. So the use of low-emission materials is recommended, especially for the architects. Talking about radon, generally trying to retrofitting for building weatherization, as it's called in the States, by applying loft and wall insulation or using triple or double or triple glazing has been shown to increase the radon levels. It is well established that radon mitigation methods, such as the sub-slab depressurization, can be effective in energy-efficient homes. MVHR, using MVHR systems, also has been shown to reduce the radon levels. However, in some cases, again, may be unpopular due to noise issues, especially from the occupants. And the passive houses, again, in the UK and the Ireland, have been shown to significantly reduce the radon levels compared to the non-passive houses. Talking about biological contaminations and the various pollutants which may be experienced in the indoor environment, I can mention, for example, that for house dust mites, mold and bacteria, this really may increase their levels, especially as a result in the warm and humid environment. However, because it's a quite tricky case, cold also conditions can increase the high risk of these levels and the high risk of relative humidity, which may lead to biological contamination. The studies shows again that mechanical ventilation with filtration reduces the increase of outdoor funking. However, it doesn't really perform better than natural ventilation regarding the removal of fungal pollutants which are generated from indoor sources. We know that damp and mold can occur in the old buildings due to poor insulation. However, damp and mold can be found also in energy efficient buildings due to inadequate ventilation or design or some construction problems which lead to thermal breaches. So generally, we expect that the green buildings can perform much better if actually all the energy retrofits have been properly executed and we don't have any increase of this biological contamination. Regarding the impact now of energy measures on health, yesterday we heard actually a presentation which was on shallow and deep retrofitting. So we were talking about deep retrofitting with fabric insulation and use of new energy efficient heating systems. The homes can be really more affordable to heat and can have an impact on health, can reduce the risk of cold-related illnesses, can improve also the physical and mental health of the occupants. If now we're talking about shallow retrofit, in this case only with loft insulation in some social housing, then this has been shown to be associated with an increase, a significant increase in admission rates for COPD, but also for cardiovascular disease. However, higher levels of boiler and glazing replacement was associated with a slightly lower admission rates, again for COPD, as a result of increased thermal comfort and warmth actually in the home environment. The PM emission strategies, yes, this has been shown to have an impact on positive impact on health. We're talking about building fabric improvements, about the provision of adequate ventilation, the switch of fuel from gas to electrification, and then we're talking also about the changes in the occupant's behavior, which is also important in order not to generate emissions in the indoor environment. So, to conclude, the literature review has shown that there is a growing body of evidence which suggests that both private and public energy efficient buildings have the potential to have good indoor air quality if the systems, the mechanical ventilation systems which are applied, are properly commissioned, installed, maintained, operated. So practically we're talking about the provision of adequate ventilation here. So if this is happening, then everything can be fine. Furthermore, there is the recommendation that building codes and performance standards should evolve to promote energy efficient measures that are resilient to future climates, and they still can protect, can improve the indoor air quality, can protect the occupant's health. And of course, we need to think always holistically and address any interactions with other aspects of the indoor environmental quality. So it's not only ventilation and indoor air quality, but we're talking about thermal comfort, lighting, and noise as well in the indoor environment. And in order really to achieve through this holistic approach the satisfaction of the occupants and also their health, and mainly their health. Thank you very much for your attention.
Thank you very much for the excellent presentation. If I may, I would like to twist a little bit this session and have it together with a forum. That means that we can have a discussion now instead of having it afterwards. So, gentlemen, it can be a discussion on your questions, and you can come back to the previous speaker at a later time. So the floor is open for questions. Who would like to ask anything? Okay. Probably you'll come back later on. Thank you.
Thank you.
Now, one question. Please do.
Only one small thing. Could you go back 2, 3, 5?
The conclusions here
No, the previous one.
on the first.
I see the second one. Loft insulation positively associated with significant increase.
Yeah.
Why?
This is what actually the study shows. I would expect that it has to do with particle concentration. It didn't report the case, but I would expect that it has to do with the particle concentration, increased particle concentrations as a result of this insulation.
Okay. It's really, really weird. I would expect exactly the opposite.
It is the combination actually with the higher levels of boiler and glazing, which practically provide the warm environment and may increase the thermal comfort in the home environment that practically reduce exposure to COPD.
Thank you very much.
Thank you.
Okay.